All right, so let's look at this one. We have lead paint. So lead was banned as an ingredient in most paints in 1978, although it is still used in some specialty paints. So lead usage in paints from 1940 to 1980 is reported in the table here. What we're supposed to do is compare the fit of a quadratic model and an exponential model for lead usage. Which model fits the data better? Then we're supposed to align the input data so that x equals 0 in 1935 and compare the fit of a quadratic and a log model for lead usage. Which model fits the data better? Because lead usage in paint was generally banned in 76, which model fits the end behavior better? And then we're going to write the quadratic model for lead paint usage. All right, so let's go get that. All right. So as before, I've gone in here, and what I went ahead and did is, we had our data. It was 1940, and we were supposed to set this uh, back to x equals 0 in 1935. So 40 would be 5, and then 15, 25, 35, 45 is kind of what we're supposed to do. And I went ahead and did that before we even started modeling anything. That way we had that already built in, and then we have our levels of lead here. And so what we were supposed to do is initially we're supposed to compare the fit for a quadratic model and an exponential model for lead usage. So let's do both. So a quadratic would be 5, and we go down here and let's call that vars 1. All right, and then let's go and do 0, which is our exponential. And again, let's put that in vars 2. Okay, now they should all be here with all the details, and let's look at our graph. All right, so this is what we have. So let's look at our window. Our window doesn't look like it would be, okay, 0, then max is, let's see, let's go ahead and go, yeah, let's put from 0 to 55. That'll work. And so that's our first point. And so now looking at that data, which one looks like it's the best fit? Well, the blue line really looks like it's the better fit for the data, as far as the quadratic goes. So that's kind of a key that it fits better. But what end behavior looks better? Well, that one kind of looks like the end behavior because this hits 0, and then I'm assuming it's going to go stay at 0. If we don't keep adding lead back into the environment, we shouldn't start going back up again. So that seems to be the trend I see anyway. So for part A, which fits the data better, well, the quadratic fits the data better, but that's that. Now, part B said compare the fit of the quadratic and the log model. Oh, and now we're supposed to do the log model. All right, so let's do the log model too. Well, we'll just throw in one more model. That's number 9. And so that's a vars 3. Have to read all the correct directions. All right, so that goes there, and that one goes there. All right, so quadratic and a log model, which one fits the data better? Well, that one, the log, it fits pretty good, but it keeps going down. So, it's making all of a sudden having negative values for our lead concentration, which doesn't make sense. So on that one, I would say our quadratic one actually is going to fit better for part B. Now, because lead and paint was used or banned in 1976, which model fits the end behavior the best? That would have to be our red one, which was this one here, the 564.22 times the 0.8, oops, 0.821 to the x. Okay, so our exponential. So that's going to be the one that actually fits the best. And then we're also supposed to write the log model, or write the quadratic model. So we'll write these two models down because those are kind of the key ones there. Well, I guess we don't have to write the which one fits best for C. It just says which one is the best fit. It didn't tell us to write it down. So, all right, lots of stuff here. So let's go ahead and kind of write these down and see what we had. So A compare the fit of the quadratic and exponential. And so we said the quadratic appeared to look better. Okay. Now we're not looking at end behavior in this one. So the quadratic fits the data given, and if it had gone back up again, it would even be a better match. Okay, but as it is, the quadratic is going to fit that data better. Let's see. So B, if we align that, compare the fit of a quadratic and log model for usage, which one fits better? Well, again, the quadratic fits better because log model gives negative concentrations. Okay, so we don't have negative concentrations. It's just going to go down and it's going to hit 0, and that's as low as it's going to go. All right, so C, because lead usage in paint was generally banned in 76, which model fits the end behavior best? Well, the end behavior best is going to be the exponential, because it comes down and then it just goes to that 0. So our exponential fits best. Okay. Now, what was the quadratic model? Because this is a quadratic section, they want us to actually do the model. So lead in thousands of tons per year. I don't know how we want to write this. We can say maybe L of X equals, and we have 0.057x squared minus 4.558x, and I think it was plus 90.789, and that's thousands or 1,000 tons amount of lead for years. All right, 4 years since, and this was from 1935, because we had said that 1935 was 0, then that's 5, 15, and so on. And so our x goes from 45 down to the 5. Okay, and that would be our function that we can use to get the data there. And again, the exponential fits the best, because how the curve goes, as far as it goes down, and then it basically is going to go towards 0. But this is the function they ask us to actually write the model for. All right. All right, so that's all I have for this section, actually. So in class, we'll do more.